We are not going to be doing anything new, but we do need to make sure that we remember the things that we've done. All right. Sokotoa. Good, Timothy. Sokotoa is our, what type of triangles does this apply to? Right angled triangles. Okay, what side is this one here? Adjacent, it's next to my angle. What's this one here? Opposite, because it's opposite my marked angle. And this one is? Hypotenuse. Good. All right. So we are also looking at bearings. So if I'm here and I'm going over to town B over here, and I tell you that town B is on a bearing. Actually, I'm going to rub that out first. Okay, actually, can you all get your books out? Because this is something that I'm going to put on your test, and you're always bad at it. Well, not you, but everyone. What? Get what? My goodness, Jumling, this is seriously at least half your classes. You don't bring your stuff. You need to be more organized. Okay. Town A is on a bearing of 75 degrees from town B. Draw that for me. I want you to draw this, please. And then I'm going to write another one down here, and you're going to draw this one as well. Should it what? Oh, very good point. I should write a 0 at the front of it, shouldn't I? I'm not telling you. It doesn't matter. We don't care about distance. I just want you to draw this. So you don't worry about the distance. I just want you to draw this. Doesn't matter how far away you draw it. All right, you've got two different things here. I want you to draw both of them, please. Draw the black one and the red one. And then we'll have a look. It's really important that you pay attention to the wording of this question, because I promise you about half the room is going to get it wrong. Read the question carefully. I am going to underline a couple of words now for you to pay attention to if you haven't already. Just do it roughly. So it doesn't have to be precise, but it should be roughly accurate. If you have not paid attention to where those two underlined words are in the sentence, you've missed something. Put them away. Put them away. All right. Town A is on a bearing of 75 degrees from town B. So which one am I starting with? Right, I'm going to start with B. Okay, this is my north line. 75 degrees is about here. A should be up here. This is 75 degrees. If you didn't draw it like that, you got it wrong. B, you must start from B. Then you're going 75 degrees towards A. I don't tell you the distance. So now that we've drawn that, I want you to write down the bearing of A to B. What is the bearing of A to B? All right, does someone have an idea what it might be? So what do you think?
Where it might be.
Sorry? 105? Incorrect. Why is it 285? Okay, this bit here is 105. Remember, bearings are always clockwise from north. So it's this bit. So it's 360 minus that. So it's actually 255. Right? The bearing of A to B, always go from the north, always go clockwise. All right, let's have a look at this one here. I said from town A. So this time, I'm going to start with town A. Again, I'm going to draw my north line. 190 degrees is more than a straight line, right? Going straight down would be 180 degrees. So actually, I'm going down here. This is 190 degrees, which makes this bit what? That is such a bad drawing, but you get my point. That is a terrible, terrible drawing. I'm gonna draw that again because it does not look helpful. Okay, if that's A, it's probably more like that. That's better. Okay. So this is 190, which makes this what? What? What did we say? 170. So what's this bit in here?
10.
10. So the bearing of B to A is 10 degrees because we have to go from the north line across to B, like from B to A. Okay, so it's really important. I am going to put that on your test. I'm going to write a sentence like this and ask you to draw it. Okay? Really important that we pay attention to the language. All right, let's do an example of, let's go back to Sokotoa. All right, can you do these two questions for me? Wow. Right, please have a go at finding those two unknowns for me. Oh, goodness. Okay, use it. Why aren't you telling me when it's straight? Normally does that. Right. I'm going to give you a minute. You can do those. We'll solve it. There's one unknown side, one unknown angle. All right. I'm just labeling them to help you in case you haven't got the right sides. So am I going to use sine, cos, or tan for this first one?
Oh.
Good. Cosine 51 equals the adjacent over the hypotenuse. How do I move the 14.2? Bring it across and multiply. And if I type that into a calculator, I get 8.94. And it's meters. All right, so this one here, I'm finding an unknown angle this time. Am I using sine, cos, or tan? Tan, because I got O and H. So tan of my angle is my opposite over my adjacent. Yeah. TOA, right? Oh, an A. No, A. All right, so my inverse, remember whenever we're finding an unknown angle, we're doing an inverse of tan. So what did you get? 46 point what? 04. Excellent. Well done. All right. How do you know whether to use the sine rule or the cosine rule? How do you know, guys? What's the difference? Which one's that? Sine rule? Good. Two sides and two angles. How do you know when to use the cosine rule? Three sides and one angle. Why can't you know three sides and one angle? What if you know three angles? Sorry, I said it the wrong way around. If you knew all three angles, would that give you information about the side lengths? It really wouldn't. Because if you had, these could be, as long as these angles are in proportion, you can make these side lengths anything you want, right? If you're just expanding a triangle, if I get out my little triangle tool and I draw a triangle like that, if I just expand this, those angles are not going to change unless I do this, right? Then they're changing. But if I just make the whole thing equally bigger, those angles don't change, but the side lengths do. So we don't need too many angles, or we can't use too many angles. Why won't that delete? There we go.